Sweet. I'm at Grin Technologies in Vancouver with Justin, the founder. How's it going?
Hello, not too bad, Corey.
Awesome. I've had so many questions just right off the bat and wanted to get the camera rolling to capture some of this stuff,
Okay.
and including, like, you've got a couple bikes parked out here, and this one seems to have like a multiple speed chain ring, or?
Yeah, so this is a Patterson 2-speed crankset.
Cool.
It clicks a lot in reverse. It's got a planetary gear drive, 1-to-1 for a normal mode, and then you can hit the overdrive 65% increase. So it gives the equivalent, in this case, of a 65-tooth chain ring, which on a 20-inch rear wheel bike is really valuable in order to have a decent pedal cadence when you're moving fast. So it's one of the early problems we had with e-bikes was just you're commuting at a much faster speed, and the normal bicycle gearing doesn't allow you to keep up, so you're spinning your legs like a bumblebee. And on 20-inch wheel bikes, it's all that much worse. But incidentally, this Patterson drive freewheels, so you can spin the chain without turning the cranks. So we took advantage of that as part of a mid-drive system for cargo bikes, which used to be on here. We took it off. You can actually, so there was a motor up here that would pull the chain from behind. We sent it down to Bike Friday because they were interested in having it as a possible cargo bike option. And then at some point they redesigned their frame, which included cross tubes that prohibited the fit of a motor, so we kind of scrapped that project. But it's illustrative of a lot of things, you know. 90% of the projects you embark on that seem cool don't actually materialize into anything.
Whoa, so to see it through this far and to have such the ability you guys have to customize things and make just excellent tools, I guess, or components, like that's the cycle harness we're looking at, right?
That's probably 50% of our business, and that's pretty much what got us where we're at. Yeah, I mean, it's sort of our namesake product when we first started to run this as a company. So I built that as a prototype just for myself when I ran an electric bike club at the university. We had no instrumentation.
Which university are we talking about?
This is UBC. So
UBC is just
you
up
had to
the
go
street,
straight that way, but on the way to UBC, there's a very strong hill to climb up, and that was my motivation for getting electric in the first place.
Okay, there's the origin story. So when did this happen? Like what year?
This was 2003, and so this was a time when there'd been e-bikes on the market since the late 1990s, you know, conversion kits from Curry, the Heinzman was a classic one, but there wasn't this Chinese phenomenon of hub motor e-bikes all over the place. I think the hub motors had just started having some market traction in about 2001, 2002, but nobody was bringing them into the West. And so back then, the most active online forum was Yahoo on a power assist. The Vias for Voltage forum existed at the same time, but Yahoo was sort of the hub of electric bike activity. And from that, I got in touch with a person who was importing these Crystalite motors. And of course, as a poor student, so I was seeing the cheapest I could possibly scavenge from him.
Do some bulk, maybe share with friends or something?
So starting off just for myself, I wanted to get my own fix so I could ride up the hills in the morning and not be late for classes.
Nice.
And then on building my own first bike, all of my classmates, the professors, everyone's jaw dropped once they actually hopped on board and ride it. And it was clear that not only was it fun, but it was something they'd never seen or ridden before that made so much sense the moment you hop on one. And back then, if you mention the word electric bike, not even 1% of the population would have heard of it. Now you're rare to find anyone who doesn't know somebody who has a friend or a brother, an uncle who has an e-bike. So we wanted to, A, get a bunch of bikes for ourselves, B, do a ton of engineering projects related to electric bike technology, because it's such a nascent phenomenon and one that clearly hadn't been developed very far in the marketplace. And then C, we wanted to see if we could make Vancouver be a local hub, and UBC specifically be sort of a ground zero for e-bikes in North America. And so from there, we did arrange some bulk purchases. We tried to get grants, failed in almost all attempts at that. And then in the end got enough interest outside of the campus, but just from people in Vancouver at large, to warrant us forming it as unrelated to UBC, just as a separate business to make electric bike conversion parts. See ya, Tom. And
there's a couple employees here that we were
That's right. So Pippa on the left does a lot of manufacturing. She actually used to do more of our accounting and bookkeeping, and she's a fine arts student as well. So she's at Emily Carr, one of the fine arts universities here, So
well, for the past 12 years you've been growing this, it seems like, and you know, when did you actually get this building?
So the first couple of years of that was trying to run a club at the university. And we incorporated the business in 200005. So we're going to come on our 10 years.
Coming up, big party?
It will. It'll be our first grand opening party. We've been musing about having a grand opening for a while now.
Do you sell out of this building, or what goes on here?
Yeah, I enjoyed being a sort of a hidden gem in the neighborhood. So there's no billboards advertising us. For the longest time we had no signage at all. But anyone who stumbled on and poked their head in would sort of be, you know, amazed to discover just how much bustling activity is going on behind those closed doors. We do a fair bit of foot traffic from Vancouver, but almost always from people who know what they're getting into in the first place.
Right,
So
that's how I got here, right?
So, and that's because we're in a very specialized side of the electric bike business, which is purely conversion kits for do-it-yourself enthusiasts. And if we have to explain from the ground up to somebody who doesn't know a volt or amp hour,
right.
Then it's a huge amount of overhead explaining what we sell and 90%.
On that subject, as someone, I've only been engaged with the electric bike space for maybe the past few years, right, since like 2012 kind of thing, and initially it was like, okay, voltage means power, amp hours is like how far you can go, and then I realized, oh, well, there's amperage too, like how much amps. Can you give like a quick breakdown of that, since you are kind of about kits?
Yes, and it's funny, so that's pretty much the sole reason why we keep the Cycle Analyst as a technical device. Because we really want to educate. So part of my mission in life is one of education. I really enjoy teaching, and I really enjoy propagating knowledge, so the common analogy with voltage is electrical pressure. That's what's forcing current through a circuit. And so the more voltage you have, the more pressure you have at your disposal to push electricity through a device. On an e-bike, voltage by itself means nothing. And one of the biggest mistakes that people make in analysis on e-bikes is, oh, I want a 48 volt e-bike. Oh, I want a 72 volt e-bike.
Right.
That by itself, it's like saying, oh, I want a 110 volt light bulb. But in Europe, you have a 220 volt light bulb. That makes no difference. A light bulb's a light bulb. A 100 watt light bulb puts out 100 watts. A 500 watt motor will be 500 watt motor, and you can design it to 500 watts with a 12 volt power at lots of current, or it could be 500 watts at 72 volts with a small current. So voltage in isolation means nothing. And the reason why most bikes are 36 or 48 volts is because it's a happy trade-off from a voltage that's not so high to be dangerous. So 72 volts, if you touch that with wet hands, you'll feel a tingle. If you touch it with bloody hands, it'll actually cause you to recoil a little bit. If you go down to 12 volts, which is really common for low voltage accessories.
In the car, right? Cigarette lighters.
So you think, well, why don't we just make all e-bikes 12 volts, then you can run all the little GPS devices, things that plug into your car would work on your e-bike. Brilliant. Except an e-bike needs to produce about 1,000 watts of power to be useful for most people. And 1,000 watts on a 12 volt circuit requires close to 100 amps. And to flow 100 amps with a 12 volt system, you need very fat copper wire.
Which is expensive, probably.
It's just unwieldy. You need big fat connectors, and on a bike, nothing's clean or tidy if you have to deal with welding gauge or hard jumper size cables in it. You could get this exact same performance. So I could build an e-bike that runs at 12 volts that has the same top speed acceleration as the next guy's 72 volt hot rod. So this is a very long-winded answer to
I know, but it's cool. I appreciate it.
So ultimately, e-bikes are usually designed between 36 to 60 volts because it's a nice trade-off where, with a 36 volt system, to do 1,000 watts, you only need 30 amps. And 30 amps you can do with sort of household wire gauge and with connectors that are, of a reasonable size.
Anderson connectors.
So Anderson's are a classic one that's good for up to 45 amps of current on a 36 volt pack. That's 1,500 watts. That's enough to address the vast majority of power requirements. The reason why people go to a higher voltage is not because a higher voltage is better performance or higher speed or anything at all. It's because if you get a motor designed for road legal speeds at 36 volts, if you run at a higher voltage, that same motor will spin at a higher speed. And for people who want to push the speed boundaries of a particular setup, there's two avenues to do that. Either you can rewind your motor so that it has fewer turns of copper and goes at a higher RPM for a given voltage, or you can just up the voltage of your battery. And upping battery voltage is a lot more accessible than opening your motor, undoing all the strands.
So you're buying in bulk from China, and there's probably a fewer
so
of
you
those
could. I mean, if you're custom ordering a motor, you can absolutely get it to perform like a hot rod at 36 volts. But most people are getting an off-the-shelf motor, and then to push the limits, specifically the speed limits, the easiest avenue is to increase the voltage. So then it creates this idea that you need a higher voltage for more power. Not at all true. Power is power, whether it's a low voltage and a high current or a high voltage and a low current. But the most essential concept for e-bike riders isn't voltage or amps so much as amp hours. And so the measure of electricity is measured in amps. So if I have a bike that's turned on, there's a voltage on the battery, but there's no amperage flowing out. And the big source of confusion for people just getting into this is they see a battery and they'll see it's rated for amps or amp hours, and they'll just confuse the two and think they're interchangeable. So as you draw current out of a battery, that current is measured in amps, just like you measure the flow of water in gallons per minute. And if you want to know for how long can you take that current out of the battery before it goes flat, that total amount you bring out is amp hours.
Yep.
And so this here is an 11 amp hour battery. So that means when I plug on my bike, pardon the lack of a switch, you'll see here, if I go to this screen, I'm drawing a tiny amount of current, 0.05 amps.
Yep.
And that's just the current that the motor controller needs just to stay powered. And I have 54 volts of pressure on that bike.
Okay.
But on the right side here, I have the running sum of how many amp hours I've taken out of it. So here, I've taken 1.79 amp hours. If I hit the throttle for a little bit, the motor's going to struggle a little since it's stalled. That amp hours will increase because I've pulled amps for a small amount of time.
What's the nominal amps that this setup draws?
So this particular one will pull a 25 amps continuous.
Okay,
no
that's
problem.
pretty powerful.
That is. It's what I like. So for me, a comfortable commuting power is about 1,000 to 1,200 watts at 40 kilometers an hour, 45 kilometers an hour.
Okay.
That's slow for some people's standards. That's very high for what others would like. For somebody who's comfortable riding a bike on the road on the highway, that's a sweet spot, I feel.
Right.
And of the systems you see here, most of what we sell ranges in the range from 500 to 1,200 or 1,500 watts.
Well, that's a really interesting point, okay, because legally speaking, there are sort of these cliffs, in America at least, where it's like 750 watts or less. They rate it based on the motor size.
They do.
And the top speed is 20, but if you pedal along, maybe up to 28. I mean...
There's I don't try to interpret the legal definitions on these things.
Yeah.
We don't sell electric bicycles. We sell components for people that are building projects, whether they want to make a legal thing on the road or something.
And you can set that with your cycle analyst, I've noticed.
Yes, any systems we sell could be configured to meet any legal regulations anywhere in the world.
Right.
But we're not selling bikes, and we're not really versed in what the specific interpretation needs to be. But the most difficult interpretation of one is power rating.
Yeah.
And so the regulation will say the motor can't be rated for more than 500 watts.
What, nominal, I guess, because a lot of them peak way above that.
Yes, and not only do they peak above that, to interpret continuous wattage, you need to specify an RPM.
Okay.
And so a given motor, so this motor that's on the front of my bike here, so this is a direct drive hub motor.
Yeah.
I could run that thing 1,000 watts continuously if I'm spinning it at 500 RPM, and it'll have no problem. It'll get hot, but it won't overheat. If I run that at 200 watts at maybe walking speed, within 10 minutes, you'd see smoke coming out of the windings. And there's no single definition for the wattage rating of a motor. It's a dynamic variable that depends on how fast you're moving, how quickly the motor's rotating.
Right.
We can analyze and predict with great accuracy how the motor temperature will respond over time, but nowhere in that is there a benchmark that says, that's the continuous power point. And it's just like if you ask a human, well, how many horsepower are you rated for, right?
Yeah.
And I throw a bear on your behind and you'll run and put out 1.5 horsepowers, and I ask you to run a marathon and you'll be lucky to sustain 0.2 horsepower over a 4-hour period.
That's a great point.
And electric motors are very similar in that regard. So
these parameters are left out. Okay, so this actually is an interesting transition point, because didn't you start the sort of the Endless Sphere forums?
No, I had nothing to do with
Were you engaged with that at all? Or
I became very engaged by circumstances almost exactly 4 years ago.
Okay.
So I'd been an active poster beforehand, and I felt the forum was an incredibly valuable resource where there was a complete lack of commercial intent behind it. It seemed like a community-driven forum whose purpose was to disseminate and share knowledge from people who were joined by this common interest in light electric vehicles.
Yeah.
And so I did my best to contribute. I did a bike trip across the country in 2007, and that was the first time I really became engaged in the whole Endless Sphere community.
Across Canada, or where did you go?
Yeah, from Vancouver to Halifax.
Sweet.
I don't like to say cross Canada because people in Newfoundland will raise a hissy fit. There's one province that goes a little further yet. So coast to coast would be the politically correct way in this country. And then afterwards, I felt it was a really interesting space to share all the R&D that we were doing. And I like to be very open and public with
transparency.
research, and specifically for that side of education.
Yes.
And so I was an active member, and I was really heartened to see the community interest and the amount of positive feedback that people gave each other for encouraging projects, and also the depth of really deep technical know-how, and people with PhDs, people with really thorough understanding of power electronics, of fluid mechanics, of electrical theory, of battery chemistry.
That's awesome.
And 4 years ago, it turned out that the person who had been hosting the forum had sold it to a third party whose goal was to monetize it. And so he had a buddy who ran a whole bunch of forums that were ad-driven forums.
Yeah.
And that caused an uproar within the community, and the long and short of that is that we ended up purchasing it back from him.
Wow.
And then now we took ownership to keep the Endless Sphere as an open place.
So you guys host it.
So yeah, so now we're the host, and we there's also a responsibility that comes with that as far as keeping it current and relevant, and it's a very changing world on the internet.
Absolutely,
and so there's more at stake than just hosting it for it to, in the years forwards, be an active gathering place. And but I hope we can maintain it.
And a positive one. Yeah, thank you for the history there, because I've only just kind of been like, he's connected to it somehow. It's, you know.
Yeah. So at the moment, there's a group of about a dozen moderators who have done a phenomenal job of keeping the peace to the extent that an open free speech place can have.
Yeah. Shout out to the moderators then, right here.
Big huge one, and and I have very little role in all of that. So I pay the bills to keep it hosted, and then I have a few of our staff with computer science skills will come in now and then and fix problems with the forum or put in enhancements.
Nice.
But
well, maybe on that note, Justin, you want to tell me a little bit about Grin and then walk me through and the products and stuff?
Standing on the street.
Yeah, this has been so cool though.
So this particular building used to be an automotive detailing shop. We used to be located for the first 4 years in a much smaller building up Main Street.
Okay.
And then growing pains expansion hit the limit of square footage, and stumbled on this place, which we had
here, I'll block the security code for you.
And then realized that this particular building had the absolute perfect mix of floor layout space that let us have a retail shop where we could have customers walk in and purchase things. It gave us a proximity to all the bike stores in Vancouver. So if you do a Google Maps search for the area, you'll find within a 5-block radius there's 12 other bike stores here. Wow. So it's kind of bike store central. Cool. We hoped that proximity would give us an avenue to sell conversion kits to bike stores. But that side of the business is one that's never really taken off in a way that we'd had some hope or promise that it would. There's always been a bit of conservatism from the bike store industry to embrace learning a whole new skill set.
Yeah, definitely.
And then, it gave us this storage and warehousing space for maintaining our stock.
Did I see electric skateboards there too?
Yeah.
My goodness.
So but why don't we just do tour-wise?
Yeah, let's do a tour.
So this is was supposed to be my head office and got taken over by engineers. Dan here is programming firmware for the Cycle Satiator universal battery charger.
Is that this thing right here?
Yes. So this has been a ground-up battery charger that can be configured for any voltage battery pack, any chemistry battery pack, and then gives in the same way the Cycle Analyst gives you your stats while you're riding your bike, this gives you statistics while you're charging your battery. So as you're charging it, you can get
some real-time feedback.
Real-time feedback. You can see exactly how many amps are flowing in, how many amp hours and watt hours went into the battery pack, and then you can see the lifetime history. So this is a freshly flashed device, so it doesn't have it, but you can know on average how long did you spend charging your batteries, how many cycles have you put on it. So there's a lot of exaggerated claims, I'll say, in the realm of battery lifespan, and we really want to empower users to actually hold vendors to task with real-world statistics of what they actually get.
That's awesome.
So when you see people saying 2,000 cycles battery, and somebody actually has the instrumentation that says, actually, I've only ever charged it 540 times, and I'm now only putting in 14 amp hours when it used to be a 20 amp hour battery.
Right.
And then gets that information into the community's hands, and then lets everything be sold honestly. And
I appreciate. Well, and on that note, do you have any advice, like anecdotal feedback for how people can help their batteries last longer?
Yeah, this was a big motivation behind the feature set in the Cycle Analyst. And I didn't know this at first. When we were first dealing with lithium batteries, I tried to find out, well, is it better? Say you have a short trip that only uses a quarter of your battery. Are you better off charging it every time you come back? So you drain it to 3/4, charge it up, drain it to 3/4, or do you keep using it until it's flat and then charge it?
Right.
And what I could find in the information 5-6 years ago was scant, and nothing really telling me, oh, you should always go, drain your battery all the way flat, or always keep it charged. And we knew the way that the battery management systems work. They only balance the cells when it was charged. So we would always advise people to, always leave your battery plugged in, charge it up, and then you're sure your cells stay balanced.
Right.
And what's become very apparent since then, and what all the automotive manufacturers I wouldn't say they discovered it. I think this knowledge has been known within the community for a while.
Oh, yeah.
And thank you, Dan. They realize that if you don't charge it fully, but you reduce your full charge voltage, the actual cycles that the modern lithium cells will put out can increase by factors of 2, factors of 4, even
Wow.
factors of 10. And we, quite often, we're seeing batteries worn out after 200 to 300 cycles. So
wow, a lithium-ion battery?
A lithium battery.
Wow.
So people would have a 10 amp hour normal e-bike battery that have a reasonably fast, powerful system. They'll go 40 kilometers an hour. They'd buy a battery from us one year, and the next year they'd say it's just not getting them to work anymore. We test it. What was a 10 amp hour battery is now 6.5 or 7. They've only charged it at most once a day, and so in a year you're not really going to get more than 300 cycles. And what we've learned is that a large part of that is that they were always held at their full charge voltage, and the cells degrade a lot faster when they're fully charged.
Some of that heat, or you just think it's the capacity has been balanced?
Voltage. I don't. I'm not a battery chemist to talk in the details of the mechanism, but it has to do really with the voltage that it's held at. Heat also has effects as well, and that's something more during the discharge. So we'd also find that people who use their battery on a powerful system will get fewer cycles than those who use them on a less powerful system.
It's like the C rating, like it's draining it faster and
you
stuff?
drain it faster, the batteries get hot and they degrade faster.
Okay.
You leave it charged in all the time, the battery voltage is high, it degrades faster.
So on that note, I've been kind of like experimenting with feedback, because I do these reviews and I try to give people that same sort of like, hey, it seems like if you keep it between 20 and 80%, that's going to be kind of your sweet spot if you're storing it and you're not using it.
That's right.
If you haven't used it for a few months, you're sort of topping it off maybe because it's gone down slightly.
This is a topic that is so BMS dependent.
Okay.
And so ideally the battery management circuit would barely drain anything from the cells. So if you just have your battery charged, it will stay charged for years and years. The reality is that the circuit that protects the battery also drains the battery. Yeah. And some drain the battery very slowly. So you could leave your battery half charged, which is the normal recommended storage charge. A year later, it might be 45% charged. Another year, 40%. It's never going to go down to 0% before you're going to want to use it again.
Cool.
Other battery management circuits will drain the battery flat within 3 or 4 months. So we've had full shipments where we bring in 50 or 100 batteries from a company, and we'd find out that the battery management circuit would draw 1 or 2 milliamps, which is small.
Phantom draw, is that what you call it?
The quiescent current is what an electrical engineer will say.
Nice, thank you.
And that 1 or 2 milliamps adds up to, over the course of a week, that might be 1/4 of an amp hour, a 1/10 of an amp hour. Yeah. But if you have a battery that's 8 amp hours and you left at 75% discharge, there's only 2 amp hours left in it. If you lose 1/4 of an amp hour every week, well, in a couple months, it's down to no more capacity. And another month after that, the cells are so low that they're dead. That has destroyed more lithium batteries that I've seen than any other misusage problem at all. And in that case, the advice is, don't let your battery drain all the way. But the advice back then would be, leave your battery plugged into the charger, charge it up. Well, that itself
that's bad too. Yeah. Okay. So it depends. Is that one of those moments?
Well, now you take one of our satiators.
Yeah.
You configure it to leave it at 50% charge, and if you really want to leave it at 50% charge, okay.
Yeah.
And so it'll kind of maintain it there. And I think that's what a lot of hybrid batteries do, or the car companies you were saying they sort of.
And so cars, and this is where we would see automotive manufacturers give 8-year, 10-year warranties on their battery, and my jaw would drop when I'd see that. I'd say, how can they possibly give a warranty when we see the batteries falling like cards after 2 years, 1.5 years? And it's because they understood that by a proper management of the state of charge. Now, you said 20 to 80%. I haven't seen any rugged evidence that going below 20% causes the same problem. It seems to be at the high end with lithium batteries. So if you had a choice between, say, going between 20 and 80% or 0 and 60%, from all the research on the topic I've looked at, the 0 says 60% is better, because then your full charge voltage
I'll start
is
using
lower
that.
still.
Yeah, thank you.
But there is that problem that some particular batteries, if you don't bring them up to 100% charge, then the BMS will never get to balance the cells. And if it's a low quality BMS or low quality cells, you get some cells that will gradually get flatter than others because they'll self-discharge, and then you may end up getting reduced pack capacity.
So that's interesting. If you have 10 cells and 9 of them are getting that voltage where you're saying, okay, well, I'm half full, but that one is not ever being balanced. It can fall all the way down. You get a bad cell, and that kind of wrecks the battery.
And then it doesn't wreck. I mean, then once that one cell's low, the battery shuts off, even though the remaining 9 still have energy in them. And that can be remedied by then balancing it, which with a lot of battery management circuits requires you to charge the battery to 100%. Some battery management circuits can balance the cells regardless of where they're at. So those ones, you wouldn't have that issue. I'm just mentioning all of these nuances because you can't give a single rule of thumb that says, this is what you should do.
Well, back to the forums. I think that's why it's been popular and people have had so much to say.
What I wish is that the manufacturers and vendors would understand this and communicate what's appropriate for the batteries that they're offering their customers. But the one challenge that we deal with is that the battery management circuit, which is so key to all of this behavior, is tied in with the battery and not usually well spec'd and will vary from batch to batch. So a company they import a battery, they specify the cells, the amp hours, the layout, how much amps the BMS needs to handle, but they don't say how the BMS should balance the cells. They leave that to the battery manufacturer, and then they source battery management circuits on the open market that meet the nominal specs. And so even for the same line of batteries, the advice that you give your customers 1 year might be totally different the next year because the properties of the BMS are going to
so let's dig into it. This is where I'm sort of just stumbling across this. I didn't even know you had this product, but I'm seeing that it has the Anderson connectors. If I bought like a Bosch battery, a Bionics battery, and I wanted to use your charger to sort of keep it balanced and maintain it, how would I do that if it has a different plug interface?
Okay, that's a good question for two reasons. One, that I don't think you understand.
Okay.
Because the two examples you brought into this mix were Bosch and Bionics. And both of those are companies that have decided to use a proprietary battery with their bicycle system.
Yes.
So with Bionics, that means that you can't use a third-party battery with your Bionics motor. It also means you can't easily use a random charger with the Bionics battery. Bionics has done something really interesting, that they've actually built a little charge circuit inside their battery. So all their batteries are charged, I think it's with 24 volts or 27 volts, and then a circuit on board boosts it up to whatever that particular pack needs. So you can use the same charger whether you have their 48 volt system or the 36 volt system.
Cool.
But you then have no control over how it's charging it. You're delegating all that control to their one battery, which manages it internally, which is taking it out of the user control. So if you're in a Bionics system, you're tied in with the Bionics ecosystem, and your ability to take control yourself over how your charge range is now.
So you can't? Is that the...
You can't. So Bosch...
I was hoping for like, you snip the wires and then you put the Anderson connectors on and you...
You could. And
it would avoid the warranty probably.
None of our customers worry about warranty. We have very little first-hand experience with Bionics because we just want to stay...
And I just picked two. I don't mean it all.
But what's interesting, so Bosch is... So we have a Bosch battery upstairs. So when we go upstairs, I'll show you that. And the Bosch one you can do by hacking the connector, doing stuff.
Okay.
And Bosch has made it so that if you just plug in any battery charger to the battery, it won't charge. And they use a three connector plug rather than the normal plus and minus for two connectors. And we thought that third wire needed a special unlocking procedure and a CAN bus communication.
Right.
All you really need is to put 5 volts there, and then that unlocks it. So the Bosch is quite easy to hack, and then we've used the Satiator to charge a Bosch battery. Now, one of the benefits of the Satiator as an upgrade charger is that it can charge it up to 8 amps of current. So I don't know if this one... Yeah, so here's an example of a charge that finished earlier this
cool.
morning.
You got like the little chart and everything?
Yeah, so this shows a real-time graph of the battery as it's charging. And so here you can see it started off charging at 8 amps. When the battery got hot, then it automatically, the charger, got hot. It rolled that current back to about 7 amps. And then this here is when the battery voltage is at its full voltage and the current ramps down to 0.
I see.
That's cool. But an 8 amp charge current is quite high compared to the standard chargers that especially most commercial e-bikes come with. It's usually a 2 to 4.
Yeah.
So 2 is common, 4 is increasingly the norm, which is good. So you might think, I'll get this charger and use it so I can charge my Bosch battery twice as fast.
Yeah.
And that'd be great. And there'd be justification in getting a sort of more expensive premium charger. But the Bosch battery, again, the battery management circuit will prohibit any charge current above 5.3 amps. So once we got it connected, figured out the plug interface, then great, let's see how it handles an 8 amp charge. And boom, it just cuts off the current right away. Then we dropped it to 6 amps, no go. 5.5 amps, no go. 5 amps, it worked. Then
there you go, you found the sweet spot.
And so 5.3. So is it worth getting a premium charger that can do 8 amps of current if your battery will only allow 5.3 to flow in it? That's a question for the end. It's not, it's a 20% increase in the charge time, but it does give you that control over the full charge voltage. And so if you're concerned about the cycle life of your Bosch battery pack, and you know that the Bosch charger charges it to 4.2 volts per cell, and you really want to charge it just to 4.05, you know you're going to get less range, but you know that it might last for 5 years rather than 2 years. Then it could be a worthwhile.
This is neat. Just the information that's available. It reminds me of like a kilowatt that you plug into the wall and you can kind of see what your devices are.
That's right. And a lot of companies and a lot of industry tries to hide technical information from their users. And it's true that for mainstream appeal, people get scared away from numbers, from voltage. But there's something empowering about actually understanding those things. And our sort of business mandate is to provide tools to educate the population about what they're using rather than to dumb it down so that it and also to avoid using common analogies that having
like that pressure voltage analogy we used. Justin.
But I apologize for that. But another one is kind of a gas gauge. And so we really talk about amp hours consumed rather than remaining in the battery, because that's something you can actually measure, where you can't actually figure out how many amp hours are left. And it's a subtle difference in interpretation. It's like having a gas gauge that's a reverse. It's instead of telling you how much gas is in the tank, it tells you how much you've taken out since the last full charge.
Yeah.
It's a little bit of a mind wrap to get around at first, and you wonder, well, that's dumb. Can't you just make it like a normal fuel gauge? But once you understand how to use it, you then become a much more empowered e-bike user, and you can predict with much greater accuracy when your battery will actually go flat on you.
Okay.
So anyways, so that's a big runabout rant. Just got a bit distracted by the station.
Well, initially it was like skateboards.
Yeah.
So is this top secret? Are we allowed to look at this?
So I had all these down at Maker Faire. Actually, the first one to start off on is that. So this was back when I was at UBC.
It's like a surf skateboard or something. You kind of got the pivot.
These actually are just there for learning. Totally unnecessary. It's a self-balancing electric skateboard.
Oh, wow.
So I built this as one of our engineering ball model projects in 2003. And the idea was to do something very much like the Segway, where you're just balancing on two wheels and then a control system keeps it level. And I did this without any gyros. So one of the things you kept hearing about the Segway technology was the use of gyroscopes and accelerometers.
Yeah.
And it was the first time an inertial control unit had made its way into a mainstream vehicle product. But instead I had what you see here are echo transducers. So that sends out an ultrasonic pulse, and then it measures how long it takes a sound wave to bounce off the ground.
Oh.
And so when a skateboard's on the ground, if it tilts forwards, then this time for the sound to rebound is reduced. And then as it's further away, it's longer. And from there you can deduce the angle.
Yeah.
But better than
Wait, so codename Dolphin, right? Is that what we're looking at here?
Codename was Emmanuel. Dolphin would have been fun.
Yeah.
The manual, of course, is a skateboard stunt where you balance on two wheels.
Yeah, absolutely. I skate.
Emmanuel.
Or I used to. It's been a while.
Well, we'll get you on one of these before you leave, because they're both really fun. So that was great. And at the time, I was so stoked at the idea of electric skateboards being a groundbreaking area for transportation. And there was some, in the same way there were early e-bikes, there were some early electric skateboards in the 2000s. X-Skate out of California was sort of the biggest proponent of that. So I had long sketched out various dreams and visions for a slick electric skateboard, and never had a chance to materialize that because running the electric bike business became all consuming. Yeah. But 3 years ago, I finally wanted to bring that out of the old dust, the woodwork, and make my dream skateboard happen. And that's what you see here. So this was the first skateboard where we had inline wheel motors. Yeah. So the standard for do-it-yourself hobby electric skateboards is to have an RC motor with a belt drive to the wheel. And so there's nobody at the time had done one with an inline wheel motor. The other thing I really wanted to get rid of was a handheld remote. And in the same way that the balancing skateboard had a very intuitive interface where you would just lean the direction you want to go, you lean back to slow down, to steer it, you just steer it like a normal board. And this deck pivots left and right that way. Wow. And there was another sensor located right here. So this is an infrared sensor that can see if that side of the deck is further or
so
farther
it's the
from you.
same thing.
And then exactly the same kind
different
of concept,
technology,
using optical rather than ultrasonic. And then it would drive one motor faster than the other. So you'd have your full degrees of freedom controlled just with body movements, with no hand joystick or throttle control. And the feeling of that was almost out of this world, because it's like boarding. You have this intuitive feel for motion that's dictated by shifting your body weight.
Does it still work? I mean,
this one I wish. So these lithium polymer batteries are, 12-year-old lithium batteries. And they actually had an internal short circuit from a BMS failure, and the control. I could bring it back if I gave me a couple. It's
pretty amazing just hearing about this thing.
I keep it as a souvenir. But what intrigued me, that the two-wheeled thing is fun, kind of novelty. I'm not sure how serious it would be as a really practical board for commuting. But the interface felt great, and I realized that you could have that same control feeling without a balancing board, but by having weight sensors that detect where the person's body weight is on the skateboard deck. And so in this case, if you look on these trucks, you'll see this little blob of epoxy over here. Here's one that's clear. So if you look at the top of that, those are strain gauges that it's a small little electric circuit that senses the stress in the surface of metal.
It's like the TMM4 torque sensor kind
Very
of
much
thing.
so, exactly. So when you step on this, the whole axle wants to bend down, and that stretches the metal here. And that tiny stretch in metal makes a minute electrical signal that can get amplified and can then sense very accurately how much weight. And this is exactly what's in your kitchen scale or your bathroom scale. So what we do is we put those on the front and the back trucks,
Yep.
and you know how much of your weight's distributed front and rear, and then by leaning on the front, you can then have a differential signal. There's more weight here, well, I'm going to put power on the motors. I put more weight on the back trucks, I can, as the motors, have a proportional brake.
That's awesome.
And just like the balancing when you lean to control, you can do that on a much more conventional four-wheeled board.
How do you feel about virtual reality, by the way? Are you into this at all?
I'm a total reality geek.
You're a reality geek?
No
Okay, because I
interest.
see a lot of
Computer
technology
games,
in
VR,
use here.
Not at all.
Oh, man.
That whole industry saddens me enormously. I see people wasting their lives away playing computer games. And
well, I was just curious. We don't need to take it down that bit. Yeah, I figured, man, this is such a cool like flying concept almost. When you talk about the self-balancing board and the sense of like moving and interacting with the world in a new way.
I mean,
it's
off the
inspiring.
record, things don't get more awesome than that experience. So it does. It feels like a hoverboard. For people who are used to surfing or snowboarding, it gives you that whole sensation on land without being at the mercy of
Do you snowboard? Do you surf?
Not at all.
No, I do both, and I love it. So this is a great team here.
So I imagine that this is what it's like for people.
Awesome. Okay, you're leaning forward, getting the acceleration. Sweet. We've got a genius in our midst here. There we go. Love it. That's awesome. Looking good. Love the lights. Oh, and there's the braking action. Sweet.
Pretty sweet.
Rad.
So anyway, this was one we built 3 years ago for Maker Faire in California.
What's this? Because you said strain gauges, and now I see like infrared LEDs or something.
No, that's nothing quite so sneaky. That's just a front bike light. So those are regular LEDs.
They're not even like, they're not going to make my socks glow?
They would make your socks glow.
But just because of reflection.
Yeah. This is more intriguing on the LED front.
Wow.
So we took these boards out at the bike raves in Vancouver and wrapped them in colored LEDs.
Oh,
and of course it's a big hit. And then I felt I just had to, from the ground up, include LEDs in the things that
How
we make.
cool is this?
Actually,
do you sell these? Or
yeah,
oh my
go.
gosh. This is so rad. And it changes colors? Oh, cool.
Yeah, and like anything from China, you always get a few strings of bad LEDs. But yeah, so anyways, the development of this, it was an idea that I'd had 12 years ago when I was a student, and then to finally actually make it happen 10 years later and have it come through exactly as I'd imagined it, it was a thrilling feeling. And then the next year we followed up with a more refined version. This used to be a lot bulkier. We had RC lithium polymer batteries. This was before the 18650s could deliver the power levels that they do nowadays.
Yeah. Much more energy dense.
And so yeah, we'll take these out in a bit and give you a spin on them.
Okay.
It's an experience. My interest in this is that the e-bikes are quite mature as an industry, and the e-bike conversion kits are all sort of commoditized products. But conversion kits for electric skateboards are still all but non-existent. And as another branch for the business, it's exactly in the same realm of personal electric transportation in a kit fashion for people who like to build and create.
So people could potentially kit their existing longboard?
I would love to have an inline motor that we supply with trucks that have strain gauges, and people could install it on any deck.
Makes sense.
And to build and make batteries that are low profile, they can just be screwed to a wooden deck without much.
From a business standpoint, though, this is a much lighter product than an electric bike. It's much smaller, so shipping becomes less of an issue, and tuning it becomes less of an issue, I would imagine, because of, there's also often like spokes that you've got to tighten turning the handlebar versus something that's compact. And you could, purpose made with the LEDs. I don't know, man. I'm just.
You're talking about as a finished product?
Yeah.
So again, the whole idea of selling a complete electric vehicle doesn't interest me.
Okay.
And so we know what our core.
Out of principle or what?
Out of the type of customer base that you attract. And I love that we deal with people who want to learn and want to get
the DIY piece of it.
And it's also one that not many other businesses would want to get into. Yeah. So we can keep our little niche without the threat of a big player coming in and then being the go-to place for all electric skateboards or electric bikes, because no company like Walmart's going to sell a conversion kit.
And you get that sort of like, okay, I can choose how fast it goes, or some of these other without
That's right. You're selling components, not a vehicle, and so as a result, you're not.
Well, I've enjoyed this piece thoroughly. Shall we go on to the bikes?
So anyway, so this room is, and this I should introduce, this is Mila. She's a student from UBC who's been doing all of our software for the last 6 months.
Sorry to interrupt you, gosh.
Oh, that's all right. It's really interesting.
She's like, I wondered about that.
So if anyone's downloaded the latest, the software for the Satiator that lets you set up all these profiles from a computer screen instead of from the button presses, that was the work of Mila.
That was you? Oh, man.
And the previous
co-op. And then we've also got applications on our website. So you've probably seen our motor simulator.
Yeah.
There's a lot of new applications that are in the works that Mila's been responsible for that you'll see announcements of sometime before the end of this summer.
Well, I've seen the distance thing where it's sort of like, how far can I go with my electric bike based on the battery and motor type? Is that,
on our website? Or
I think you have like
it does. It totally
a range
does.
estimator thing, right?
It does. I mean, it gives for a certain point, but
have you been to your website lately?
It's let's just have a quick look here. So this is the actual one. So if I look at what you're used to, what you would probably referring to as a motor simulator, and this lets you pick and choose. Say, I want to see how would this motor perform with, say, a 48-volt battery, and let's go with a higher current motor controller. Simulate. And this shows on flat ground you would hit 53 kilometers an hour. That's the point where the power to move the bike, which is the black line, intersects the motor's output power, which is the red line. So if you're pedaling, then you can move a bit faster because now the motor power is putting out less than you need to move the bike, but that difference would be made up by your legs. And down here you can see the range. So you'd have 16-kilometer range at that point.
That's the piece I was interested in, right? That range.
Now say you're going up a hill, 3% hill. Well, now your speed slows down to 47 and your range drops down to 12 kilometers.
Phenomenal.
But this doesn't do a trip. It just does single point.
Okay.
And so what Mila's been working on quite extensively is to let us do an actual trip. So if you had biked here rather than driven here.
I'm so sorry.
We could have taken the route that you took.
It's a hybrid at least.
So where did you come from? You were in Whistler,
Austin,
right?
Texas. Well,
Austin, right?
Yeah.
Let's
go Whistler, right? I was in Alta.
Okay, so we're going to come to Whistler right up here. And so say you started in Whistler. Let's just say right there.
Or something, yeah.
And now you biked your way, I'm imagining, all the way down to Grin, which is going to be, wow, do I not know Vancouver? There we go. So we're 4th and Ontario. So that's going to be Quebec, Ontario. We're right here. And that's the trip. So this is, let's say, actually, you know what? Instead of taking the highway, you decided to go, no, you took the highway.
Yeah.
You've got a fast e-bike. This is now plotting the elevation profile of that trip. So starting in Whistler, this is your route down.
Yeah,
and
I could have just coasted the whole way.
A good chunk of the way. And then what this here is showing, now we've got it with we could choose a given hub motor. You know what, is our live site broken right now?
I think there's just a lot of data.
It's a large data.
Yeah.
These live demos, I tell you.
So, yeah, it is but ultimately this is showing the motor core temperature and the motor shell temperature, but instead you could plot, what's the gravity resistance, what's your wind resistance as a function of this trip, and then you could highlight sections and see, well, to go down this hill, how much regenerative braking energy went back into the motor. You could look at exactly how much battery capacity you would need between any 2 points.
Right.
And so, but to do this kind of simulation, we need a very exact computational model for how the motor, the battery, and all that behaves.
And she does it.
And she implements so I write the equations and get the data, and then say you can make this into a user interface on the website that doesn't require downloading any software. So we're trying to make everything as web applications.
I love that. And by the way, so it's ebikes.ca. We were talking a lot about Grin, and I just want to make sure people know, where to go.
It's hard. Branding and name identification is
it's hard to do everything. Yeah.
Suffice to say, I got the domain ebikes.ca well before Grin Technologies existed as a company name, but I became attached to that domain.
Sweet.
So anyways,
thanks, you guys.
That's the first step of the tour.
Okay, sweet.
We don't have much of a display center. We tried to make a little wall of at least showing the Grin products, so when customers come in, we can give them a little preview. Normally, these are all powered up and live.
Can you tell me the primary difference between your last-gen Cycle Analyst V2 and the newer V3?
Yes, for sure. In fact, I can do that right from the screens here. So the original Cycle Analyst intent was to be a dashboard to show what's going on with your vehicle, but it wasn't really there to control your vehicle. So you had your e-bike. At the time, there were no displays, so you had 5 LEDs. You wanted to know a lot more than that. you could plug in the cycle analyst to almost any setup, and then it would show you, well, how many amp hours you go, how many watt hours of battery do you use per kilometer traveled,
right?
All the stuff you'd have on a normal bike computer, but it would have only a limited role in controlling the bike. You could set it up if you wanted a low voltage cutoff to protect your battery from over discharging, but it was limited in the kind of controller interfaces that it could do. And what happened about 5 years ago is people were really pushing the envelope of what their do-it-yourself bikes could do, and they needed an additional realm of sensors. They needed temperature sensors on their motor because they were burning up the windings, and there was also a lot of awareness about additional human bike interface sensors at the time. So torque sensors measuring the human pedal torque was an intriguing one. What's your pedal cadence? And so we thought it'd be really useful to make a dashboard device that actually could take all that sensor information in. Another one is brake cutoffs.
Oh yeah.
And then let the user decide how all those signals are going to be manipulated and ultimately control the power going to the hub motor.
Right.
So the version 3 cycle analyst has a ton of more cables coming out of it for a bunch of extra sensors. So, this is for a variable adjustment if you want to adjust your torque limit or your current limit on the fly. This here is for an electric brake cutoff to do regenerative braking. This is for a temperature sensor. This plug here is for a torque sensor or a pedal cadence sensor.
Sweet.
And it allowed us, before the realm of all those sensors was one that was only accessible to turnkey bicycle manufacturers and OEMs.
Yeah.
It wasn't really available to the do-it-yourself type, and we wanted to bring those sensors and put them in the realm of what a do-it-yourself enthusiast could include on their bike.
Yeah, and I've seen them on sort of thinking the Stealth Bomber.
Yeah, they've made their way. We have a few OEM customers, and it's appropriate for small companies that are starting off with production numbers in the 100 or 200, and yeah, there's a lot of really more mainstream displays available, especially now.
Yeah.
But we still have, at any point, we usually have 3 or 4 OEM e-bike manufacturers that have that as their standard display. So, anyway, so quick display wall. We have a lot of parts that we do in our manufacturing that don't quite pass QC. As well as customer returns that we refurbish that make functional again. And so we have a little garage corner for those who are on a tight budget in the Vancouver area. This here was, you've probably seen a lot of these.
Oh yeah, the unicycle type of standing.
Self-balancing. So I built that as in the unicycle parlance, it's called a BC wheel.
Okay.
And I built that, what's are we talking, 5 years ago now? It was the year before it actually came out as a commercial product.
Cool.
And met the guy who's actually just north of Portland in Vancouver, Washington, who brought it to commercial. Now you just see them everywhere. But it's that.
Do you patent any of this stuff? I see stuff in here like the torque sensor that I know that Bionics and the TMM4, they share a certain IP on that.
That's a whole dozen. Quick answer is no. We don't patent anything. We discuss every idea that we have so that it's in the public domain and not easily patented. Or if someone wanted to claim a patent on it, we could say, no, well, we posted about this on the internet in 2004. We built a working example of it. And so your patent from 2008 clearly is not going to apply.
That's neat.
Yeah, so anyway, so over here we have a unicycle corner, which has nothing to do with electric bikes, so we'll skip over that. There's a little overlap on the left there. So that's a variable geared electric assist unicycle that I built for Unicon, which is an international unicycle convention every 2 years. I do think there's an interesting niche space of commuter unicycles that have an electric boost on them.
Sweet.
So in the realm of business areas we can get into that no other sane business would consider, that's one of them that might make sense for us.
Definitely.
The one area we deal with a lot of the niche areas of electric conversions, and one of the ones that's really near and dear to us is cargo bikes. The cargo bikes add so much utility to a bicycle as a practical car alternative.
Yes.
But they demand electric assist much more than a regular bike would, even for people who are otherwise pretty fit cyclists.
Yeah.
So we developed in-house, this is the final result of what we showed you outside on the street a bit earlier, where we have a motor that's assisting the chain. And so the motor drives pulling on the chain from the rear, and then even if you're not pedaling, it can turn the front chainring over. But this is designed really as a pedal assist system, because when I do pedal the motor, if I'm pushing down here, you can imagine, in fact, if I push the back brake, you might even be able to see it, but there's a lot of stress in this bracket. So if I squish the brake and push down on the pedal, you
I see some bending happening.
Exactly. So that bending is sensed by, again, one of those strain sensor force meters, and communicated to the cycle analyst so that this bike is smart in knowing how much pedal effort you're putting in, and then drives the motor proportional to your torque, just like Bionics, but but without needing an expensive torque sensing bottom bracket.
Well, talking about price, how much are some of your kits?
Not all that cheap. So this particular one it's $1,500 for everything without the battery.
Okay.
But that's including, you know, the 2-speed chainring crankset. So this alone is like a $350, $400 part.
Yeah.
And that's including the version 3 cycle analyst, the motor hardware, and a lot of parts that we CNC machine ourselves in small numbers. So it's definitely a specialty product that only makes sense for people who need the specific feature set that it has. We're not ever going to attempt to try to compete with Bafang's BBOS bottom bracket.
Right, yeah. And that's okay. I like the niche, and I hadn't really seen or heard of the Metropolis. I don't know how to refer to that, but yeah, I've seen the FNAO. I've seen the Schlumpf drive. It's sort of similar.
This is just like the Schlumpf. You could actually use a Schlumpf on this kit just fine. It's just the Schlumpf is, you're talking about $1,500 just for the bottom bracket. Super high quality and a lovely product. The Metropolis is just at that.
So that's the one that you guys kind of package in.
But I mean, to be honest, it's been a bit of a source of headache. So we've had about a 10% failure rate on just this part. Whereas if we went with the Schlumpf, I'm sure they would have been. Do
you have any comments about warranty for Grin products? Or?
Yeah, we do. So everything we manufacture, we do 3 years minimum.
Wow.
And but we don't have nearly as much control over things that we import. And our business is about half and half: products we design and make and products that we import.
Yeah. Like that's sort of packed into your
That's
kit.
right. So this we would go with the 3 years on that because it's part of a bundle kit that we do, even though we didn't manufacture it. And but if it becomes a sore point for us, it throws into question.
Of course, you change the relationship if you need to. Yeah. And you've got the refurbished rack. So I get it. I see the whole full life cycle going on here.
There's more things on this bike. So this here is a battery anchor rack that lets you attach your battery pack to just about any tube on your bicycle. So that's another thing where we used our CNC. It's CNC mill, which I'll show you in a back, to fabricate a part to address something that the existing kit supply that we get from didn't. They had a battery with a rail on it, but it only fit on the rear rack of their own special rack.
Right.
And that's not flexible enough for the diverse applications that our customers have. If you look over here, this is another sort of specialty kit that we just brought to market earlier this year. And so this is a Brompton folding bicycle.
Yeah, very popular.
It's very popular, incredibly well made, a very exquisitely refined piece of machinery, really.
Yeah.
And but to make a kit that fit with it posed a lot more challenge than any of the other retrofits we've had to work on, because there's particular spacing requirements, but also the folding requirement means that the wire routing now has to not interfere, and then when it's all folded, it can't be exposed in a way that can get damaged in travel. And even little details like the fork. The fork itself uses a tiny 8mm axle rather than the normal 10mm, so we had to do a specialty narrow one, a special mini torque arm for it.
Because that's where the wiring is.
I mean, it's in some sense they're all really trivial parts to make, but to get it all together, it ends up always being more of an undertaking than you usually think. We'll just whip up a few little adapters.
It'll be great.
And then it's always 6 months later before things really roll out. This is Anne-Sophie. So Anne-Sophie runs the unicycle shop. She's my partner.
Awesome.
In life and love.
Oh, really? Okay. Well, I loved your helmet, and the whole thing matched earlier. I was like, who's that girl who's running around?
So Anne-Sophie looks after all of our administration and high-level accounting.
Sweet.
And overseeing the.
Does she like pandas?
The pandas are a gift from China that she didn't love, but our former lady on sales was quite fond.
She's like, oh no, everyone's gonna think I hate pandas now. It's all good. Nice to meet you, Anne-Sophie.
So Washington is not needed. So this is our little manufacturing corner.
Yes.
So this place used to be completely dominated with cycle analyst manufacturing, and as I said, that was our major product in the business. But it got so overwhelming just to keep that process flowing, and it inhibited our ability to develop new products that we ended up finding third-party contract manufacturers to do the majority of the assembly. Cool. And then we only need to do the final QC, and then that freed up the space and the staffing and the manpower to innovate and invent new things.
When did that transition happen, and where do they make them now? Like, is there another place?
Yeah, so that we actually work with 4 different, we have the parts injection molded from a company in Milwaukee, so the enclosure, the display membranes, the assembly itself and the circuit board assembly all happens in China, and then the programming, calibration, and all of that we do here.
And do you sell globally? Because I'm from the U.S., and so I'm familiar with your products. We're here in Canada, and I know there's kind of
anyone who's in the do-it-yourself scene will know of us regardless of where. So
I'm sure.
There's our business is maybe 20% Canada, 40% U.S. US and 40% everywhere else in the world.
Okay.
So Europe, Australia, New Zealand are huge, but we've sent stuff to South America, to Asia, to Japan.
Well, in case it's the first time someone's seen it, it's like, great, I can get this
but
anywhere in the world, basically.
And it's been interesting how global of a community the do-it-yourself scene is, and especially you'll see this on Analyst, where people of all backgrounds and origins are all in this sort of motion together. So even though there's a lot of regional differentiation in turnkey electric bicycles, the conversion kit scene there's a lot more shared interest. And
well, science, it's like the universal language.
It's
I suppose
very
you could
much
say.
so anyway, so looking here, so this a lot of the parts that we make in-house, we deal with resin impregnated potted components as a way of making our things really rugged. So this started off, if you look here,
I saw the potted example earlier. Look at that.
So it all started with us making bike lights, and I was really fed up with the lifespan of commercial.
Make bike lights too?
Yeah.
Sweet.
Let's see if we come here. So this was really one of these things that just grew out of my frustration with having so many rear flashing lights fail on me. So they get wet from water damage, they'd crash my bike, and they'd shatter in a million pieces. And I just thought, wouldn't it be great if I had one that was a solid blob of just super rough, tough resin, and that had a really robust electrical circuit that could run at any voltage. So this light we developed, I guess, 7 years ago now, and there's very little change has been needed to it. It's been a popular seller ever since.
Nice.
And then in the process of figuring out and refining the techniques to do that, we realized we could apply it to a lot more products than just the bike lights.
Right.
So as we got doing more and more of that, we had to invest in equipment to more efficiently deal with it. So at the moment we have a positive displacement resin pump here.
Cool.
So just at the push of a button you can get
some resin.
Proper ratios of two-component resin. If I was doing a bunch of stuff, I'd plop on a static mix tube, so it would come out already mixed, bubble-free, and then could go straight into the molds for one of the products.
That's
that we're
fun.
making. So these are motor controllers. This has been a partnership product between ourselves and a company in Toronto. The Toronto company designed and developed a very sophisticated motor controller, but we didn't like the physical geometry of it, and so we thought, well, could we not take your circuit board but package it in a way that works as an aftermarket motor controller for
and
an
looks
e-bike.
cool.
And looks cool. And the clear was really just done experimentally so I could see how things oriented themselves inside. And when we posted pictures of it, people's jaws dropped when they saw the clear. And now probably 70% of the ones we've sold, people have wanted clear resin. So we offer every color. We have a whole assortment of different dyes.
Wow, that's fun.
So here's a pair of those in their molds being cured right now. And then quite a bit more recently, we had a similar sort of brainwave about doing the same thing with battery packs.
18650s right here?
Yeah, so this is a battery pack that we've been mulling about for about a year and a half, doing a battery that was less than 100 watt hours, and that has two big advantages. One, it's below the threshold that you can take on airplanes. So if you were to fly like here with a folding bicycle, you need a battery less than 100 watt hours. You can bring 3, 4, 5 of them, that's no problem, just individually they have to be less than that. And then that also simplifies the shipping process. So not just air travel, but when we want to ship it to a customer, it costs us somewhere between $100 to $150 to ship a battery to the US with all the hazardous materials requirements. And then this falls again below the regulatory threshold for that.
Are these Panasonic cells?
These ones are Samsung 25Rs. Okay. We'll look into doing there's any range of.
Is this like a Lego a grid here that they click together?
So you'll notice the name on here, the LIGO battery for lithium on the go. But interestingly, of course, we have our little indexing dots.
Yes.
So the whole idea now is that you can stack your battery together. They'll align themselves neatly.
Dual
both
bolts,
goes right through.
Couple bolts.
Exactly. And if you want to go end to end, you can stack them that way.
Sweet.
These bolts all line up in a row so that you can then make one sort of monolithic battery pack.
I love it.
And then you just parallel connect them. Now the other advantage from a shipping side is that you now have redundancy in your battery pack. So instead of, with the current system, you have one big $1,000 battery, there's one BMS circuit. If that one circuit fails, fritzes, gets water damage, your whole battery's out of commission.
Oh, yeah.
Now we've distributed that, so instead of one big battery, you'd have 10 of these bolted together.
And could you use your charger to kind of test it and be like, this is the one that's bad, I need another one?
Our charger could totally tell you that. Hopefully they wouldn't fail in that way, but if they did, you'd still have 9 working batteries.
Yeah.
And so from the reliability of an end user, and then if we had to do a warranty thing, they're now just shipping this little thing back, they still have 9 batteries to run their bike with.
Very
we can
clever.
send them a replacement and not have to deal with. In fact, it's basically illegal for a customer to return ship a battery. So unless they're trained in hazardous materials shipping and have the certification to show that, they're actually not allowed to return ship the battery to you. But then one of our challenges, of course, is if we want to make a part with an enclosure, the cost to tool up the mold for an enclosure is minimum about $10,000.
Wow.
And takes quite a few months, if not usually a year, between all of your prototype testing and validation.
Yeah.
And so we sort of had this brainwave, well, why don't we try potting it? But potting by itself makes a pretty brittle enclosure. So it's actually got fiberglass. Ignore the sparkles.
Oh, wow.
This is just us having fun.
Yeah,
But
that's
if
cool.
you look a little more closely, actually, I think on the black ones, you can sort of see the weave under there.
Yeah.
So this one didn't get quite enough black dye in it. So that's actually a fiberglass sleeve around there, which makes it incredibly tough. So the requirements for batteries is that it can stand a 1 meter drop test.
Oh.
This will drop at a meter fine. You could drop it off the
Is that what it
balcony
is?
there.
Balcony up here? You got the drop test zone?
It varies, but it's pretty much exactly 5 meters. And so we were able to do 5 meter drop tests on the battery pack.
Sweet.
So this.
Well, very clever, Justin. It's neat to see you engineering the business paradigm as well as the products, and in terms of shipping and in terms of modular.
Yeah, and this
replacement.
is something that we only encounter from our own headache of dealing with that business side of things, and seeing what a headache it was for not only our business but any other business in the space. And
Introduce these two guys here. I met you earlier.
Hi.
Okay, Bella,
Yes.
right?
Right.
And then
Sawa.
Soho. Okay, sweet.
Hi.
Howdy. This is awesome. You guys were working on these,
Yep.
doing some soldering earlier and getting the motor controllers ready.
Yes, and if you
for
look
potting.
if you look closely at this motor controller, you'll see that there's a sort of a film of resin already on it.
Yeah.
And that's a really soft silicone coating. And what that does is it provides a mechanical barrier between the really rather brittle epoxy resin that does the full enclosure and the circuitry, so that if you get if you get local hotspots, things expand and shrink. You don't want to put mechanical stress on these circuit parts.
The sensitive areas.
Exactly.
I
So
see.
these are now covered in basically a piece of clear rubber, and then any shear stresses aren't going to transfer through and risk breaking or cracking electrical components.
Very cool.
So there's a lot of details like that we have to take precautionary measures with. That from making the bike lights and other products, we've learned what's required for this potting technique to
Love
pull
it.
up to real world.
Thanks, guys.
All right. So normally John will be here, packing and shipping headquarters.
Nice. And photos.
And
Check
a
that
photo
out.
booth is essential if you run a website.
Sweet. I have some pretty nice hands, Justin. I don't know if you want a hand model. We could work something out later.
This is what my hands look like.
That's
true worker hands.
It shows that you've been doing stuff, you've been making it.
And so normally any given day we'll have a bunch of orders that will be printed off and stacked in here, and then usually there'll be 15 to 20 shipments going out the door, scattered throughout the world.
Seems like business is good. I mean, you got a number of employees and a really cool space and in an increasingly expensive part of the world, Vancouver.
Yeah, well, the Canadian dollar's dropped a lot the last few months, so that's been
Need some more
nice
American
uptick.
orders. That's what I hear.
It helps us a lot.
Yeah.
Robbie, who you met previously.
Robbie,
is,
how's it going, man?
Design engineers, technicians, and overall.
Yeah, is this going to be another one of those like epoxy?
This is going to be a potted battery. So what I'm going to show you in a little bit, we've been doing destructive testing on these batteries to see how the potting affects the thermal runaway behavior. So if you have a fault that actually causes the battery to go in a meltdown and vent, is the act of enclosing it in a casing, is that going to make it worse, or is it going to help contain things?
It's like the Tesla thing where they've got special sort
That's
of
right.
enclosure.
So Tesla's really gone out of their way to scrutinize this. We need to do something similar on a much smaller scale. And so I'll show you the results of an experiment we did previously. And Robbie's soon going to be setting one up where we has, not on this one, but where we're going to be putting little spacers between the cells. When the cells get really hot, the heat shrink that covers them melts away.
Okay.
And then you have metal to metal beside each other. And if the metal to metal from the heating ends up making contact, then you get a short circuit between cells.
Makes sense.
So we did an experiment that was spectacular, and I'll send you the link to it.
Oh,
We got
sweet.
it all videotaped on an infrared camera. But you see, they kind of fall like dominoes. One cell goes into thermal runaway; it gets glowing red hot in an infrared camera. Visually, it just smokes a bunch, and then the neighboring cells get really hot, and then the neighboring cells, and then one by one, they just work their way down. Even though there's no current flowing, they, the cell here, but after 10 minutes of this one going thermal runaway, this one over here goes into thermal runaway. So we want to understand that mechanism a little bit better, and then if we can address it in the design of these batteries, we'll do that before we bring it to market.
Cool, Robbie. Awesome. Thank you.
So this is out of an e-bike repair corner. So we can test hub motors, drop them in here. We have all the soldering, crimping tools that you would want to use.
What's the coolest tool? You got to pick one. What is it? What's the coolest tool, Robbie?
Spoke machine, Robbie.
Oh, that's pretty sweet, actually, yeah. Here I was going to say there's nice strippers.
Okay.
Nice.
Well, everyone has their own preference on wire strippers. You'll never get consensus on the best wire stripper. We keep every variety under the sun. I used to be a huge fan of these single action wire fox. There's a bunch of cheap Chinese wire strippers like this that aren't even worth the $2 that they cost. But these, they wear out over time. So you end up some that work really good on a certain type of cable sheath and others that were good on thinner gauge wire.
And I heard you say spoke machine though too, because I mean that's a lot of work to.
It's not a good machine.
Okay, the right tool makes all the difference, right?
The spoke machine so that was really the first big tool that I invested in. So this is just after being a student, not having any real money in the bank account, to spend $3,000 on a piece of machine.
How much that was right there?
It was an earlier version. It was a Philwood machine. It was $3,000. Wow. That one was as well. And it seems like an enormous sum to spend on something just to make spokes, and was the best purchase I ever made.
Awesome.
And it also just awakened me to the fact that good equipment always pays for itself.
Awesome.
And you'll see some development along those lines.
And good employees too. Like, thanks for introducing me. It's fun to see,
Yeah, Robbie's been a great employee. And then this here is more general bike mechanic stuff. Even though we don't install conversion kits here, we very often have people, so like here's a customer's e-bike that has issues, so they brought it in, and so we can actually run it on the bench and see what's specific.
kind of nice. That's the advantage of being local, I suppose.
Yeah, but it's something that if we open the door up to anybody, we'd be overwhelmed. So there's a real shortage of shops. So we'll only take in a bike that has components on it that we sold.
Yeah.
There's a huge shortage of actual e-bike service places.
Who's this friendly guy?
This is Arthur.
Arthur's
our regular summer employee. So he goes to school in the other 8 months of the year, and has been an absolutely invaluable shop hand. And you'll see some of the really fine work he's done upstairs. Right now, he's actually building a part for our motor dynamometer. So I showed you that motor simulator.
Yeah.
All the data from that comes to me testing on some equipment that's up in the lab. And we're doing some refinements. We can handle higher power motors without flying apart on me.
So dynamometer, is that how you measure and test your...
That's right.
It's a dyno,
It's a dyno, yeah. Okay. And you'll get a good look at it.
We'll get... Yes, Arthur. Awesome.
So this has been my latest project. And so if you find that Grin projects aren't moving along fast enough, it's because I became boat obsessed for a little while.
Isn't that like a hole you throw money into in the water or something?
Normally, this one is more one I put time into.
Nice.
So it's a sliding seat rowboat, but I've actually embedded addressable LEDs all the way down the oars. So when we're riding at night, the whole oars light up, and then they can change colors as you're rowing and can be 6.
Is that how you met that cute girl at the front desk?
This is a huge incentive for me to build this boat. This is a joint project for us to fall in love over. She chose the color scheme. She's much in an aqua phase at the moment.
I've noticed, right? Her shirt, her helmet, everything was...
She used to have an aqua bike that I got her, but that sadly got snipped away from one of the bike racks.
You need to make some theft products here, maybe.
The world needs to make theft products.
But it sucks because that's like the most wasteful type of product. It's a lock. It like doesn't help the first user, and it mildly inhibits the second user of it, and it just wastes shipping weight.
I'm intrigued to see smart locks making their way on the market that do a little
like
bit
alarms,
more.
GPS, and
That's
stuff.
right, and GPS tracking could maybe finally break the cycle. Or to just in the same way that they do bait cars to really crack down on car theft, and it works great.
That's true.
And if there's a similar theme where people in this ring of bike theft would, now they do it with impunity, and if there was a 1 in 10 chance they were stealing a trackable bicycle, I think it would crack it down enormously.
I would love to see the police force in America focus on issues like that. That would be awesome.
And I'd be just as happy in Canada. And
really? Okay.
Apparently they really don't.
But
so we've lost a few. A lot of people actually asked about the theft of e-bikes, thinking that, well, it's a much more expensive bike, that they must be targeted much more. But I think it's all theft of opportunity. I don't think e-bikes are ever targeted. People often steal an e-bike, and then it comes as a surprise to them that it's an electric bike.
Oh, yeah, and they're like, what the heck?
Yeah, and then
where's the charger?
Often they get abandoned for lack of a charger, or we see them on Craigslist where people have hacked them open trying to figure out how to power the thing and made a big mess. Anyway, so this whole area here is our prototyping and R&D shop. So I used to have a garage of my own full of these metal shop tools. I then moved to a float house on a marina. Hence my desire to have a boat so I can commute to Grin by rowboat.
Is that where you still live? You live in the marina?
I now live on a marina, yeah.
Sweet.
So you came in from North Vancouver and you would have driven right past the marina that I live at. So it's about a 15-kilometer trip through the water. So I'm really hoping for the day where I can row that one challenge, you're not allowed to row a boat under the bridge. So there's the Lionsgate Bridge is a famous bridge over Stanley Park. So you need to have a motor assist. So this is part of why this whole boat is going to be hooked up electrically. You'll see I'm going to have a cycle analyst mounted here.
So the electric rowboat.
I'm going to do a little outboard driven by an e-bike hub motor, spinning a high-efficient airplane propeller, so that when we're doing those sections through the bridge, I can be under motor power.
It's more of that like remote control design that I saw on the skateboards a little bit. If you're talking about.
What I'd really have to do is actually put strain gauges on here, so that as you're rowing, this whole thing flexes backwards, and then I can power the boat based on your rowing effort.
Huh? Oh, that like rowing assist.
Yeah,
in a sense. Yes.
So and again, it ties into this realm of personal electric assist transportation, which for me is my whole motivation in this space. A lot of people get mistaken and think that I'm all about electric vehicles. I couldn't care less if the electric's convenient. I have a background in electrical engineering. I understand it very well. It's a universal currency for trading and storing energy. But if e-bikes were powered by gasoline or methanol or what have you, it would still be just as good. It's still 1/20th to 1/40th the energy of a car.
Yeah.
And it's such a human sizing, bringing transportation to a human scale. You go faster in the city and you use orders of magnitude less primary energy.
Yes, and you say that, are you talking about people ingesting fuel and powering themselves?
That comes into the equation too. And we had to take a sustainability course as part of my engineering degree at UBC.
Well-rounded.
And on that topic, there's an opportunity to do a term paper on a subject of your choosing, specifically a life cycle analysis. So this is in 2003 when there wasn't a whole lot of info available, but I did delve into what the numbers were for the life cycle energy comparisons of electric bicycles compared to normal bicycles. And if you treat the human as a machine who consumes food to produce power, we're abysmal. As far as just food calories to mechanical calories, it's like the same as a car engine, like 20-25%. But then to make food calories, you're usually putting in 5 to 10 times more fossil fuels to produce. So you put in 10 calories of fuel burning to make 1 calorie of the food that you ingest. It doesn't need to be that way, of course. With local agriculture and low intensity harvesting, you can get human power close to electric, but never quite as good.
Right.
And that's including all the energy to produce and procure the battery, all the chemical extraction for the cells. The battery recycling is a bit of a different topic than the energy side of things. So that just more has to do with contamination. I don't know if often it takes more energy to recycle a product than to make it from scratch. And so paper is a classic example of that, where sure, recycling is good, it reduces the trees that you cut down, but you actually put in a lot more kilowatt hours of primary energy to go through that process. Batteries have a phenomenal historic recycling rate.
Lead acid, is that because they were historically lead acid?
But also all the lithium batteries, there's drop-off boxes at every place that sells power tools, Best Buy, they all have a battery drop-off. I don't really know, I know the e-bike batteries, we ship them to a place in the interior of British Columbia, actually. There's a huge battery recycling facility there that harvests batteries from all over North America. But there's an energy penalty to transporting them back to a common place for recycling. But the point about the e-bike is that you're using, like I say, a 50th the energy that you'd be using in a car. So even if the recycling is horrendously inefficient, even if the batteries take a ton of energy to make, you're already so many leaps and bounds ahead by virtue of the fact that you're moving in a small vehicle.
Yes.
And that applies whether it's the skateboard, the bicycle, the self-balancing, one-wheeled unicycles, the mono-pedal unicycle. All these light electric vehicles consume about the same amount of energy. And it's the energy to move a human around the city at 30 to 40 kilometers an hour. It's about 10 watt hours per kilometer. And you do it in a car and you're using 200 to 300 watt hours per kilometer. And there's just no need for that. And it's not only is there no need, it causes all kinds of deaths and injury. It uses up a huge amount of our real estate. And people are coming to terms with that. And that all cities are taking a very aggressive stance at encouraging car alternative transportation and trying to open up their city centers to pedestrians to bikes.
And virtual reality, telepresence. Justin, come on. Thank you. I'm just, having fun with it. And, I've my own opinions on the space, but I personally appreciate sort of the community aspect of it in addition to the health and efficiency.
Yeah. Well, and then you interact with your neighbors, right?
Yeah.
Like you smile and wave at people when you pass them on a bicycle or you're stopped.
And your company's called Grin, and you can't stop smiling. Is there a name?
It's for our hope is that our customers are Grin.
Okay, that's the goal. Okay.
Because I can't stop smiling.
Yeah, you've got this infectious. Well, life seems pretty good, man. You've been doing a good thing, helping people out with your product, and your employees seem really happy too. It's heartwarming.
Well, we'll hope it stays that way. So we do a lot of warehousing. So we get container loads of hub motors every month or two. We have a container come in, and so again, I mentioned just the advantage of the space, having everything under one roof, where you can do warehousing, where you can do metal manufacturing, you can do front end sales, and you can do, as we'll see upstairs, all of our engineering.
Nice.
So
we climbing a ladder? How are we getting up there?
not unheard of. We'll take the safe route for the sake of your camera.
Yeah, I've only got one hand. Up and away we go.
All right.
Sweet.
So engineering headquarters, normally quite busy with 5 or 6 guys. Right now we have 3 of them who are overseas doing a factory inspection right now.
Oh, cool.
And normally this would be my corner, the big messy section. So this is the dynamometer. I could put a bit more lighting if it's a bit dark in here.
Sweet. If I go on the other side of you, then the light seems to work better this way.
But yeah, in a heartbeat, I can show you this. Normally, to use this device, you would connect this motor to this motor. So here's a motor under test, and this is the motor that I'm controlling the motor with. Huh. All the torque output of this motor is coupled through the magnetic field of this motor through this axle here that's connected to a load cell that has those same strain sensors on it. So you see this common theme of strain sensors appearing in all kinds of products that we involve ourselves in. It's a curiosity. I first got acquainted with strain sensors when I was a pyrotechnic enthusiast for measuring the thrust of rocket engines.
Have you ever been to Burning Man? You mentioned pyrotechnic enthusiast here.
So you'll see playa dust on a lot of these old products.
Really? Okay.
But yeah, so this here then lets me measure. So if I spin this,
do you have an oscilloscope? Are we looking at?
This is an oscilloscope right
Sweet.
here. Sweet. There we go. So this here lets me dial in a given RPM, and this motor will maintain that speed regardless of whether this motor is trying to speed it up or slow it down. So it's kind of like simulating a given speed on the ground.
Yeah.
And no matter how much I try to use this in regenerative motion as a brake, or I try to motor faster, this will always fight it. And then while it's doing that, it's telling me how much torque it needs in order to sustain that RPM.
I see. So it's kind of subtracting the two, and you're getting...
Yeah, and I'm getting an exact readout of the torque of this motor, and can then compare what the efficiency, the power output, how fast it's heating. I can measure that and then make an exact numeric model that we can then simulate so that people have no mystery or question. When they pick and choose components for a given application, we can say just how it's going to perform.
Rad, very precise.
So I've done testing on a huge number of motors. So this is just a small fraction of the motor wall. A lot of these are motors that we've never stocked, but they're pretty popular for users.
So I see there's the 8-fun 350 watt.
Exactly. Some of these are motors that are pretty oddball. This is a Crystalite G-series motor with a weird spoke flange that we really have no interest in carrying.
Wow.
A lot of small geared motors that I had interest in for small conversion kits we never really got.
Do you want to go over the parts of a motor, just very briefly, since you've got an open one?
Well, this isn't just any open motor. So this is actually a Grin motor. If you look closely,
okay.
The side plate there.
Look at that.
So I had this idea for a hub motor that had a very large diameter ball bearing on the side cover in order to facilitate a lot more interaction from the inside of the motor to the outside world. Part of that can be for moving heat out, for better cooling. Part of that is so you can use heavier gauge wire. Part of that is for installation. It's super annoying to have the wires coming through an axle.
Yeah,
but a major component was that most advanced suspension fork bikes use through axle hubs.
They do, yeah.
Right? And so this is a very typical
15
hub.
millimeter.
That's right. So here's a 20 millimeter through axle, which was popular for downhill bikes in the past. Nowadays, 15 millimeters is a little bit more common. So there's been no hub motors, and there's still no hub motors on the market for through axle motors. So this is 4 years ago I started designing this, thinking, oh yeah, a motor that's, should be easy peasy to design, and then get one of the motor manufacturers overseas to produce it for us. And like anything, you find out everything's 10 times more involved than you initially hoped.
Yeah.
But one of the things I just did in this, the actual motor core here, so the copper windings in the stator, that is exactly the same as you'll find in almost any of these very generic Chinese direct drive hub motors. And my feeling at the time was that the electrical performance of the motors didn't leave a whole lot to improve on. 88%, 89% efficiency, very economic in the way that they're manufactured. But where I saw a huge amount of opportunity to improve the hub motor experience for North American bikes was in the mechanical interface. So make it work with through axle hubs instead of normal hubs, not have wires coming out through the middle of the axle. Add the facility for additional cooling capability, and also make it lighter. And there's a lot of weight.
Especially in a direct drive.
Yeah, well, exactly. So here's the standard direct drive hub motor. So you look at this. This is a steel ring that's about 9 millimeters thick, but you need the magnets glued to steel because the magnetic field has to flow through steel to go from the north of one face to the south of the other.
Yeah.
But you don't need it to be that thick. Okay. So the motor is this thick just so that you can fit a bolt in order to screw the side cover on.
I see.
And so just for mechanical reasons they made it, but steel's super heavy. So you're adding all of this steel that's not part of the magnetic circuit just so that you can have a threaded hole to bolt something onto.
Yes.
And feel the weight of that.
Oh yeah.
By comparison, all this is doing is providing magnets in the backing plate. We can do that with exactly the same capability using just the very minimal. So here you see the steel, rather than getting thick on the sides, I actually make it much thinner.
Yeah.
And but then that left me with the challenge, well, how do I actually bolt it together? And I was initially going to have a flange on the side of this that came up just so the bolt holes would go in, which you'll actually see on a lot of these other motors. But then it dawned on me that we also don't need the magnets to butt up against each other. When you have two magnets touching as the edge, the fields just cancel out. And so it's convenient for assembly when you can just slide them. But if you leave a gap between them, you get the same performance with less weight, less cost of magnets, and if you're sneaky, you can actually fit a screw that goes right through that slot into the other side. Here you'll see the magnets are scattered all over because they did a very poor job gluing it. But yeah, with that idea on hand, we then designed the side cover so that the screws, rather than going
you have more of them, they're a little bit slimmer, it looks like.
It's a long, skinny screw that then bolts on the other side. So I don't have an assembled motor here because it's on my bike.
Yeah, this is pretty, okay.
So the overall effect, by doing that, by trying to reduce all the unnecessary weight everywhere we saw it, using an aluminum rather than a steel core, making the axle load of aluminum instead of steel, we turned what's normally a 6-kilo motor. So the direct drive motor is 6 kilos, that's 14 pounds.
Yeah.
And
thank you for the conversion.
to 3.9 kilos.
Wow.
So taking off 35% of the weight.
Yeah.
And that is actually the same weight as a geared motor. So you look at like this Bafang geared hubs, those are usually about 3.7, 3.8 kilos. So we could do a direct drive motor that weighs as light as a geared motor, but has the benefits of regenerative braking. And
right.
simplicity.
Well, what is, okay, so two concerns with regenerative braking. There's usually some cogging that slows you down slightly that I notice when I spin the wheel and it's, you know.
You're talking about concerns with direct drive motors.
Yeah.
Yes. Yeah, there is. So that's another interesting side of the discussion here. One of the things you would intuitively think you'd want to do is maximize the strength of the magnets.
Yeah.
So you think, if I have stronger magnets, I'll get more torque out of the motor for a given amount of current. And it's true. So you can get the highest spec magnets you can, and you'll see an increase in the torque, but you'll also see a very large increase in the drag of the motor.
That's what I'm talking about. Yes, this cogging.
And so what I found is that if you reduce the magnetic field strength and actually use slightly weaker magnets, it's true that the output torque might be only 10% less, but the cogging torque might be 50% less. And in the trade-off of the end user experience, a lot of people would trade off having a much easier ride when they're not using the motor at the expense of a little less off.
I love it. So it's a lighter motor. It's a little bit easier to ride. You still have regen. What's the efficiency on that sort of energy take back?
It's everything on a motor is speed dependent. The faster the motor spins, the more efficient. The efficiency of using the motor as a generator is exactly the same as the efficiency of using it as a motor. So going at 30 kilometers an hour, if the motor is 80% efficient to make power, it's roughly 80% efficient recovering it.
Okay.
That's a little bit of an irrelevant aside because the big benefit for regen is saving wear on your brake pads.
Yeah. And
so many people emphasize, they minimize, they say, you only get 3 to 6% energy recovered from regen. It's not worth it. It's not worth it. If you have a direct drive motor, there's no reason not to do regen because you always have that little drag there.
Yeah.
It's no more complex of a motor controller.
I see it skipped so often though. So why? We're getting a similar weight as this smaller internally geared planetary geared motor, and we're doing it with direct drive gearless. So if you're saving a little bit of wear on the brake pads, what are the other advantages? Is it just durability?
As you say, a little bit. My own experience is about 4 to 5 times longer brake life.
Okay.
So like 80% of my braking I do with regen, and the mechanical brakes only kick in on those panic brake moments or when you really need to come to a complete stop abruptly. So that's, for me, the cost of disc brake pads, they're like $20 to $40 for a set. It's not totally cheap.
Okay.
The inconvenience is a real hassle. And I put off replacing my brake pads until they are squealing and I'm like metal on metal. Just because it's a nuisance in my life. I have enough things going on. I don't want to have to do
rather build a boat with LED oars. I love it. Don't get me wrong. I appreciate where you're coming from, and you haven't commented on the durability, but that's something I hear a lot, is that there's just not a lot of moving parts aside the bearings.
Yeah. Well, so what's intriguing about that is our empirical experience is that when we look at our stats for motor returns, and we keep track of, we have an RMA system for return goods coming to us. We're up to almost 1,700 packages we've received back to us. So parts that have failed that we've had customers send back to us for repair or service. So we have a huge history over the last 10 years of seeing everything that can and has gone wrong. And we see very similar return statistics on the direct drive motors as the geared motors. And
Oh,
the direct drive motors are a lot more prone to water damage. Because they're so big, there's a large air cavity that expands and contracts. So as the motor gets hot and cold.
It gets hot and cold here in Vancouver, right?
But when you use the motor, it gets hot.
Yep.
And when you park your bike, it gets cold. And if you park your bike in the rain as it's cooling, the motor's turning a suction, and then it sucks water. Any little cracks, water builds up in the cracks and gets pulled in.
Well, like an hour ago when we were looking at your bike, there were holes already in it. Is that so that there's...
That's exactly. It's to equalize the pressure. It lets air flow, so it allows the motor to run more coolly, and most importantly, it allows any water that comes in to just get driven right out again.
Beautiful.
But it also opens the motor up to exposure.
Yeah,
so
dust and stuff.
So one of the downsides of making the motor so light is that there's a lot less metal to just absorb the heat when the motor's running. And as a result, the motor overheats faster. So even though you've shaved off weight, you've made it run with a little bit less drag, when you're taking it up a mountain climb, you'll suddenly get the motor inside at 120 degrees Celsius, and at a point where you then get concerned for the
Well, the magnets can melt off, right?
The magnets can demagnetize a little bit, the glues can soften and weaken, and the efficiency becomes really poor. When
So what's the solution? I know you've thought about this.
So this is our examination of solutions.
Woohoo!
And so...
is this okay to show? I don't want to give away all your competitive advantages.
I've been posting this on Endless Sphere quite a bit lately.
Awesome.
So this is, I mentioned Arthur had a much bigger project upstairs, so he's been lately running our wind tunnel apparatus. So this will normally be streaming an infrared camera. And what this whole system lets us do is measure the actual motor temperatures while it's running in an environment that's simulating what it's like when you're riding. So this here is showing the motor side cover temperatures as the motor's running. That's going to get hotter and hotter and hotter until it reaches sort of a steady state temperature. And then we can extract the data and understand the limitations and the rate of heating. But more importantly, we can then quantify how different cooling strategies work. So this most straightforward cooling strategy is going to be to drill holes in it, and then passing air has a chance to flow through it.
Air cooled.
And that does a lot. But then is it a 20% improvement or an 80% improvement? Not many people had those numbers, and it's not really that easy to. You can do anecdotal experiments, but to do it in a reproducible lab environment, we weren't able to ever find any.
So you're still working on the heat thing. So you've got it light, you've got it
That's right.
fairly efficient.
And now that introduced a heat problem that really wasn't there as bad in the original motors. And this is where this dialogue on Endless Sphere has been really interesting for us, because while we're discussing the results of our experiments, showing the data, seeing that it dispels some myths and then confirms others that people had.
Right.
And before this, everybody was winging it. People were making fanes, they were making impeller blades. Some people would have fans inside the motor that were powered by tapping into the volts in the windings.
For real, like a little fan on the side. That's awesome.
And all around the inside. Some people had a fan on the outside with a jet that pointed it so it would blow air into the holes. The one thing that came up on Endless Sphere that seems like a brilliant proposal is actually to use ferrofluid. So we know that oil cooling works great. If you put a bit of oil in the motor, it moves the heat from the hot copper windings to the shell of the motor, and the passing air cools off the shell very effectively. When you're stopped, it doesn't, but when you're rolling, it's a huge effect that the moving air has on keeping the motor cool. But the trick now is how do you get it from the stationary windings that aren't moving to this moving side cover? There's an air barrier. If instead there was a liquid, it flows easily. The liquids will spill, they'll get through the wires, through the bearings. It's a very difficult job to oil seal a motor, especially when it's not designed from the ground up. And since I've already designed that motor, it's too late to add a seal after the fact.
I see.
But one intriguing proposal was to use ferrofluids, which is an oil that has magnetic particles in it that's attracted to magnetic fields. And if you put that oil in, it should get sucked into the perimeter where the magnets are and have no desire to leave that area because it's held in magnetically. And that would be a way of locally containing the oil to the region of interest without adding it. So this is something we'll be able to test. And in the coming months, you'll see a lot of posts on Endless Sphere with us showing thermal camera data, plots of the temperature versus time, and just putting numeric quantities to these cooling strategies, and hopefully find one strategy that will let us finally bring our motor into production.
Having a blast with this. I can't wait. I'm going to hang out with you guys in VR.
This one looks like no end of it.
Yeah. Well, one of the coolest parts about the tunnel is the drive for the impeller is actually one of our three-stoker motors.
Sweet.
Yeah.
Look at that. You guys are eating your own dog food around here. That's what that's called.
It's turned out pretty well.
Yeah.
And you'll see all the instrumentation is Cycle-Analyst. So we use these for actually measuring the motor temperature, 41 degrees. That's going to climb up to like 120 by the time this test is done.
Wow.
And then when a lot of the products we make consider repurposed as R&D products as well. And so this thing, like if we crank it all the way up, we'll be able to get.
Oh man. I just like. Oh boy, precarious situation here.
Terrifying for the pedestrians down below.
I know, they're like, what's happening? I thought that was just to keep the place cool up here.
It works for that too.
I sent a photo of this to a landlord and said, when the landlord doesn't provide us air conditioning, we'll go instead.
DIY. Well, if he or she is working with you, they already know there's crazy things happening in
I
here.
do hope he takes the cue and shows up here. Okay, sounds good.
Sweet.
Anyway, so normally we do all of our. This is where all the R&D for developing the Satiator charger.
Yep.
And then our electrical engineer is doing the circuit board layout and design.
Sweet. Is this like a rapid prototyper?
This is a
type
laser cutting machine.
Oh, it's a laser cutter. Okay.
And that's useful for engraving anodized parts and for making.
With that little Grin logo? Is that what I saw?
You see it now and then. We're gradually getting our logo on parts. Very late in the game on the whole idea of branding, but I've come to appreciate the importance.
You talked about crystallite with your motors, so it's just some manufacturer in Asia that's making those for you once you get the design?
Well, we need to sort that out. So I've actually got, if you look here, like here's a whole bunch of the components. So I've got all the parts to make almost 100 motors here in Vancouver.
What's this new motor called, by the way?
So that, if you notice, if you look at our product history, we usually spend a fair bit of effort coming up with sort of creative and appropriate names.
Yeah.
And that hasn't happened for the motor yet.
Ah.
But we got these actually made by a Japanese die casting firm that has very high quality standards. And then again, like those steel rings we had made by a pipe company that does custom pipe CNC machining. So they had a standard diameter pipe that was close
Makes
to what we
sense.
needed.
Yeah.
So we work with appropriate raw manufacturers for all the bare components, and then the final assembly, we'll start it off here. At the end of the day, I don't think we can set a motor assembly line in Vancouver that makes any sense. It's tricky to get the throughput, and it's a lot of overhead to manage.
Yeah.
Yeah, that's in the future.
Very cool stuff.
We'll get to.
Are you guys rock climbers too? I see some crash pads.
This is for
it's yoga.
handstands.
Handstands.
It's my therapy at 2 a.m. when I'm having stuck in
working up here.
Of some kind. There's more guys are into climbing. Robbie will usually have scars on his hands for weekend adventures.
Nice.
This here is an actual optical black tunnel that we can use for characterizing the performance of bicycle lights. So you saw that we had some e-bike lights that we designed, and this lets us, we put the light a given distance away and we have it on a rotary stage, so we can rotate up and down, and then we can map the brightness versus angle profile. And there's a lot of problems now with people riding with unnecessarily bright bike lights, and so it's super blinding to oncoming cyclists. It annoys cars, and in Germany especially, and in much of Europe, there's a lot of regulation on what's allowed in the world.
Really? Oh, that's
nothing
awesome.
like that in North America, and it needs to come into play because it is really offensive to be biking and have somebody's brake light just make you take a double take and close your eyes as you pass them. So we want to work on our own bike light designs that adhere to this idea that you light up the road and you don't let any light above into the
I've seen little covers some of them have, like a little brim.
So a little brim is like the kind of poor man's way, and you need a pretty big brim. If you have a bright light with a big emitter, you actually need quite a large little eyelid coming over the top to block that light. But if you can do your own optics, then it opens up the possibility of engineering. So here's a little stand that we did. So you saw these lights that we had before where we can rotate the angle, and so we're plotting the angle here versus the brightness landing on our light sensor.
That's cool.
All the skateboard R&D.
Skateboards,
I use a lot of RC airplane motors. I can't stand the quality of hobby grade components. A lot of people use them in electric vehicles. I find them grossly inappropriate in their overall build standards and reliability. But I see the appeal for the low cost they have it, but they've kind of driven the cost to the point of where they sacrifice so much in terms of reliability and ruggedness. No, it's too bad. We had some prototypes of machined polished mirrors that we made, and then done in a very specific way to have this light pattern that has just a really sharp cutoff. And I had hoped that we could. Here's top secret stuff.
Oh man.
So this here is a little experiment I hope to resume again, but the idea for this is a universal throttle that you don't need to slide onto your handlebar. So one of the difficulties with normal throttles is that if you have a curved handlebar, then you have to you can't actually move the throttle over it. And in order to install a throttle, you have to take off your grip, take off your shifter, take off your brake lever. And some grips you can take off easily, others it's a real pain to slide the grip off. So we wanted a throttle that you could just give a little space between your grip and your shifter.
And then just join it.
So this would just pop onto the bar, it tightens with the set screw. but you'll notice that there's no moving parts on the throttle. So we're experimenting with having force-sensitive resistors where you just push, and the harder you push, the faster you go. And then you can communicate the throttle level with a row of LEDs. So instead of having a sliding lever, you just have a non-moving static component. There's also variants like this where you can just slide your thumb up and down, so it's kind of like a touch screen.
Yeah, like on the phone or something.
And so you can be up, more throttle, less throttle, and that to us is manufacturable. We can we can make on our CNC machine. If we had to make a throttle that you actually twist, there's a lot more parts, little springs. These they break,
they break. Let go of it, and
it's not. It lends itself well to China assembly and China manufacturing, but for what we do, if we can make all the mechanical parts just fixed, and then do the proportionality just with electronics, we can eliminate multiple mechanical areas of failure.
It's interesting to talk about throttles here because you were talking about torque sensing strain gauge earlier.
Yeah.
So do your kits, they offer kind of both avenues right now? Do you have like trigger throttles? Or?
Yeah, of course. So every kit that we have can be equipped either with a torque sensor or a throttle or both.
Yeah.
And the torque sensing thing, maybe a quarter of our customers go for that.
Yeah.
Almost everyone has a throttle. Some just will choose not to install it, but they'll keep it as backup. Once you ride with a torque sensing bike on any regular commuting, having to always twist the throttle just gets tiresome. You don't realize how much of a relief it is not to have to worry about a throttle until you've ridden one without one. So I was a skeptic for the longest time until I actually got into experimenting with it, and then I finally saw the light that it's a much more joyous experience.
Yeah.
But yeah, there's a company in North Vancouver that specializes in making various force-sensitive resistors, and we're going to get them to custom fabricate one that's got just the right geometry for this curved surface area, and then possibly have a Grin throttle that approaches the throttle with a totally different approach. Instead of a twisting action, it's just a push or a slider, and then communicates that with a row of LEDs. And of course, with all the circuit board would be in a tiny little thing in the top.
Did a few more LEDs, you could have an actual little face that smiles as you go faster. Put the Grin touch on it. And real quick, Justin, I hate to take you off track, but I just want to break this down for people who might have only seen like purpose-built electric bikes. You have kits. The kits fit what range of wheels?
They fit every bike under the sun.
16-inch wheel, because you have the spoke machine. You kind of do that custom, or
some bikes. So folding bikes often have a narrower dropout than normal, but we've now got motors specifically narrow form factors, like the Brompton. Dahans are the same way. The Bike Friday has some nice folding bikes with narrow forks, fat bikes are one thing that pose a bit of challenge because they have a much wider than normal axle spacing. So normally that's addressed by using a rear motor on the front of a fat bike. But otherwise, the kind of bikes that people commute in all the time, if you have a bike, there's a kit for it. And if you have an internal hub on the back, you'd typically use a motor on the front. If you have just a normal derailleur gear system, you have an option of a front or a rear motor.
Do you have a comment on the added weight on that front wheel and how that might impact steering and stuff?
It has no impact. It's the most common asked question. Some people say that they swear they feel a difference. I really want to do just a blind test.
Is it centripetal force that sort of counteracts the weight?
The weight is right in the middle, so the centripetal behavior when you have mass right at the hub, it has no bearing on that. It's only weight out at the rim that contributes to it. And then if you did have weight on the rim, the front would feel a lot more stable. So if you could ride it hands-free more easily.
Right.
And the only issue with front motors is above a certain torque, the front doesn't have enough weight on it and the wheel will spin out.
Right.
So at the power levels we normally deal with, 500 to 1,000 watts, you don't run into that. You do if you're on gravel roads. Okay. So if you ride out in the countryside and you have a long dirt driveway, then a front hub could skid on the driveway and you might be better equipped with the rear. Between mid-drives and hub motors, I'm very much in the hub motor camp for the most part, just because I've been so sold on the simplicity and elegance of the motor, and I like the redundancy of having the electric drive totally independent of the mechanical, and that means a failure in one doesn't impede the other. So if you have a mid-drive system and then your motor F's up and jams, and that also means you can't pedal anymore either.
Yeah.
And then a mid-drive also puts more strain on the bike chain and the bike gears than they're normally engineered to take.
You have to have shift sensing and all that. How well does it work? And I mean, there is the argument of the efficiency of it operating at optimal RPM versus sort of a variable range on a hub.
I could write a white paper on the myth of optimal RPM.
Okay.
It's true that motors are less efficient at low RPMs. There's no such thing as an optimal RPM. It's true, like going up a steep hill, if you don't gear down a hub motor, then you're during that hill climb, your motor will be running less efficiently than if you were gearing it.
Right.
what is the overall effect over the course of a trip, where hills are only a small percent of the trip, it's usually really neither here nor there. So if you look at the stats on a Cycle Analyst, if people ride with the hub motor or ride with the mid-drive, in a really hilly terrain, the mid-drive might get 5-10% better. Most riding where you stop and go on flat-ish with minor hills, you won't really see a difference.
While we're on the topic, because you're busting kind of some myths, things that I've actually propagated a little bit while I'm riding. You park the bike and it's like, there's more weight in the front, and I try to qualify that in my own terms. Coming back to mid-drives, one of the things that I like to highlight is that you've got that lower sort of centered weight versus having 7-8 pounds at the rear, which would increase sort of the unsprung weight on a full suspension bike application.
I feel like it's negligible. People have a very fine-tuned sense of their bicycle, and I don't know how much of that is like you really need to do a blind test. So
I like the blind testing bicycle. This proposal here.
I'd love to do it. It's dangerous to ride a bike blindfolded, so this is where I struggle with the logistics of carrying it out. But if you could be sitting on a bike, have no way of knowing if the hub motor is in the front or rear, and it would require a motor that doesn't vibrate, because you'll feel it on the handlebars if you have a system that has a lot of vibration. I would love to be able to do a blind test and see if people can actually properly predict.
Maybe we can virtualize a test like that.
Don't you dare. I'll see the test, so I guarantee you that.
That's awesome.
So we're often spending a lot of time. A lot of people come to us saying, "Oh, I want a rear conversion kit." And the first thing is, "Oh, why do you want rear? Can you explain it?" And half the time they have no valid reason for it. It's just they're under this impression they need it on the back, and a lot of that's spread from people who do have reason for it, but it doesn't.
And suspension. I'm like the unsprung weight thing. I've noticed definitely noticed that if I have a front drive hub motor and I'm accelerating and I have a suspension fork, it's going to put some sort of lateral pressure on that, and the suspension won't actually.
So that's an interesting point. So the lateral force on a fork when you're accelerating is way less than you have on that same fork when you're braking. So when you
true, if you're using your front brake.
That's right. And so a fork is designed to handle you coming to a grinding halt with your front brake. And that force is 4 to 5 times more than the motor when you full throttle, right?
That's true.
You can stop in 10 meters.
So if you're stopping or starting with the hub motor, your suspension isn't going to slide as
assuming that the suspension's not very great. Like, I would imagine that those who do, like when you're going downhill on a suspension bike, you're riding your front brake all the time.
That's a good point.
They better well be engineering.
But you also have more weight over the suspension at a time, so it's about I don't know.
To be honest, I'm not a skilled enough or experienced enough cyclist to be dialed into those subtle differences. My own just like, I hop on a bike and ride it. It serves me well, and I just say hogwash to those that think that
awesome.
They may be partly right. They may just have a lot of myths in their own brain that they justify, and that
it's all application specific. It's fun to chat about this stuff. So being with someone who's so technically minded and you have access to this, you test it. I really appreciate your perspective.
And I hope I inspire more people to do analytic testing. And virtual reality helmet is not going to do it for you as much as you'd like. Some stuff like a wind tunnel is not within reach, but I'm really hoping that we can make, and that's why I really disclose our test methodology, because a lot of this stuff really is accessible to people. Yeah. You can actually really characterize the thermal behavior of a motor just picking it off the ground, running it full throttle, measuring the temperature, and even though that's not the same, you won't reach the same heat you get riding on the road, by seeing the steady state temperature differences and knowing how much power you're going in, a lot of the equations the coefficients that I'm finding, you can find it with rudimentary techniques, and not many, not everyone has a scientific background and approaches everything in life analytically, but I'm hoping that more people do embrace quantifying things.
I agree, and this kind of interview thing has hopefully helped. It's inspiring.
If people can spread the word to. What am I trying to say?
Do some tests.
Yeah.
Don't just hop on that bandwagon.
There's a lot
mythology.
That's right. And so I do. Yeah. And it makes for some dynamic and fun interactions on Endless Fear, and there's a lot of heated debate. And I try to just settle the score now and then by just saying, well, hey, just like.
Here's a study or something. Let's measure this. It's awesome.
And I don't mean to end the debate, but I mean to at least steer it in a direction that's backed up by experimental data rather than backed up by people's intuitions, which aren't always
our vested interests, as it were.
Anyways, that's pretty much all of Grin. As a last place, we have a luncheon. So we try to keep the team here engaged. Oh, hello.
Sweet. Hey, I recognize some of these faces here. How's it going?
So these are Anne-Sophie's parents who just came in from France yesterday.
Hey.
A wall of fame and shame. You talked about naming. We definitely do a lot of brainstorming on our product naming, and you can see
Phase Runner.
That's what dialed it in the after our democratic vote process.
Does this say kitchen cupcakes? Because I feel like I came at the wrong time. If it does.
Kitchen cupboard if you're interested in joining in on the cleaning tasks.
Oh, that's what that is.
Cupboard is right over here. We can,
Sweet.
Yeah, so every Monday our shop is closed for walk-in customers so that we can catch up on weekend orders and get a chance to square everyone off for the what's on the week's agenda. So we'll have a weekly meeting to go over their priorities and queues.
It's a recruiting opportunity here. Do you have interns, or what's it like here?
Anyone who's willing to work for very little pay and has an enormously good work ethic.
There we go.
Is welcome to drop by. In fact, a lot of the crew who come here just kind of showed up, and so there's actually a German fellow who would be here tomorrow if you came.
It's a stray cat recruiting method. I like that.
In the end, it's fulfilled 70% of our recruiting needs. We haven't even bothered making a post. Someone will just show up and say, hey, I came across you guys on the net. I like what you do. I'm in Vancouver, and but no, I'm not doing a recruiting dive. I'm really was going to offer you something to drink, but I think the fridge is actually empty.
Well, maybe do you have anything else to say? I mean, we've had so much fun.
Well, I want to thank you for all of your contributions and doing really, for the most part, unprejudiced reviews.
Thank you. I'm not perfect, man. I make mistakes, and I try my best.
But it's nice to see someone centralize all that information. So one of the downsides of an open public forum like Analyst is that it's very hard to organize all that information that's out there, and stuff gets lost in the shuffle. And you've made a very tidy, organized summary of a whole range of products out there to help people looking for the turnkey electric bikes to find the thing that suits their needs.
Sweet, thank you.
And yeah, you've done a really good job of compiling that in the last few years of your life. And,
it's true.
And keep at it. And if I know the conversion kit space is quite a bit different than the
but positive. I've always been sort of like open to both. That's why I came here today. I wanted to take a look and give you guys a chance to share your message, right? And connect people and all that. Thank you, Justin.
Okay, I appreciate it. Thank you very much. Great. Right.
Look at that handshake. Awesome.
I just passing you some of my grease. So now you can have work.
I'm official. Look at this. This is great.